So hello everyone, welcome to this new video. So in our previous sessions we have discussed a lot of sums related to source transformation and source shifting, and we have solved around 6 to 7 problems. So those who have not seen that video, so my humble request to you all to please see those videos, because those videos are very important. And also I would like to share those videos. This whole playlist is available in our channel, you can share it. And today I'm going to discuss one more problem related to source shifting, and I'm going to start with a new topic, that is star delta transformation. Okay, about the resistors connected in star connection as well as delta connection. So before that, let's see one simple problem, okay, related to source shifting. The circuit looks very complex, but believe me, it's very simple. So in this way the question would be given. Okay, similar kind of question was asked in the previous year question paper. Okay, now the values were changed, but this is that similar kind of question I'm going to discuss. So here first I told you to analyze to use the source shifting. First, in this case you should be doing the source shifting. Here two source shifting are possible. So here you can see that this current source can be splitted like this, and after splitting we should be making sure that the current source should be in parallel with the resistance. And also, so here the voltage source can also be shifted here like this for between these two branches, and we know that after shifting the voltage source would be in series with the resistance. So that's why these two shifting of sources is possible in this case, two also. So that's why both of them have shifted, keeping in direction the mind. Okay, the direction should not be opposite side. Okay, the direction should be continuous. Here also, if this comes here, it would be plus minus, and if this goes here, it would be minus plus. That also you should be keeping in mind. Okay, this is the first step. I've written the circuit here after source shifting. Then what we should be doing is these two current source in parallel we should be converting into voltage source in series. So that's what it would be happening. 2 ohm and voltage source V equal to I into R. 45 2s are 90 volt with minus plus sign indicating the direction of the arrow mark. Then down also it is 5 ohm and 45 5s are 225 volt. Then this 10 ohm 30 volt, all of them have kept it as it is. Then these all four components are in series here in this line. So 10 ohm plus 2 ohm, that would be 12 ohm, and 90 volt and 30 volt, we have two different opposite polarities, so we need to subtract, and the greater polarity is for this minus plus. So I've kept this minus plus, and 90 minus 30 is 60 volt. So 5 ohm 10 ohm is 15 ohm. This 225 volt I've kept it as it is, and here these two are in a series connection. I've converted it in parallel connection by adding a current source. That is I equal to V by R. 30 by 3 is 10 ampere with the current direction. 3 ohm I've kept it as it is, and 6 ohm. Then we can see that these two are in parallel. Okay, before that, how to reduce this is, these two are in series, so convert them into parallel with the current source like this. Okay, after that, here these two current sources you can subtract, because these two have different polarities. So the greater polarity is this one, so this I've kept it here. 15 minus 5 is 10 ampere. 12 ohm and 15 ohm are in parallel, so 12 into 15 divided by 12 plus 15 is 180 by 17. If we calculate it, we would be getting across approximately 10.58 ohm. Okay, here also this 10 ampere, can keep it as it is. Then these two are in parallel. 3 into 6 divided by 3 plus 6 is 9, so 18 by 9 is 2 ohm. Okay, after that, final step is convert it into voltage with series resistance like this. So V is equal to I into R. 10 into 10.58 is 105.8, and 10.58 ohm as it is. Here 2 ohm as it is. Then V equal to I into R. 10 ampere into 2 ohm, that is 20 volt. Then finally these two we should be adding the voltage sources. Here we have opposite polarities, so we need to subtract them. This is the greater polarity, keep it as it is. 105.8 minus 20 volt is 85.8 volt. Then 10.58 plus 2 ohm is 12.58 ohm. So this is how we should be reducing the circuit between the terminals A and B up to this form. Okay, this is our final answer. So please note this problem down. Okay, this is one more problem related to source shifting. So hope you understood this problem. So now let's get to the very important concept called as star delta transformation. Okay, we have once derivation. I'm going to explain that derivation in this session and wind up this session, and from the next session we are going to solve problems. Okay, yeah, so this is that concept. The name of the concept is conversion of delta network to star network, and also we have one more derivation of conversion of star network to delta network. Okay, the derivation would be asked for 10 marks. Okay, you cannot be neglecting the derivation part. It's very easy. So here I'm going to tell you the delta network connection. How the delta network, or we can call it as a triangular network. Delta, only the name suggests this is delta. Like this, the delta network would be there. Okay, it is also called as a pi network or a pi connection. Okay, either the delta would be network would be connected in this way, or it would be connected in this way. Okay, so that's why it is called as a triangular connection or a pi network. Delta network or pi network, it is one and the same. In this way, the delta connections would be made. Similarly, how the star connections would be made is like this: star network, that is in this way the star network connections would be made. It is also called as a T network, that is you can even write this like this also, one and the same. Okay, star network or T network. So these are basically delta network and star network. So now how to make this conversion is, we should be making the to convert delta network or pi network into star network or T network, we have one certain set of equations and or derivations. That is, considering the terminal A and B, assuming there is no branch at C. Okay, consider only the terminals A and B in this case. Now equivalent impedance between A and B is given as like this, this is in one connection like this. Equivalent impedance between A and B is given as Z of AB is equal to Z of A into Z of C plus Z of B divided by Z of A plus Z of B plus Z of C. Name it as equation 1. So now in a star connected network, equivalent impedance between A and B, assuming there is no branch at C, that is Z of A B is equal to Z1 plus Z2 in this case, because equivalent impedance between A and B where there is no branch at C. So that's why what we should be considering is equivalent impedance between A and B. After connection or converting delta network to star, we should be considering only these two impedances. So it would be Z1 plus Z2. Name it as equation 2. Now equate 1 and 2. Okay, so what we would be getting? This would be equal to this. Similarly, considering the terminals B and C, assuming no connection at A. Now consider the terminals only B and C and no connection at A. So that's why what we would be get, the impedances here are Z2 and Z3. So that's why what we would be getting, Z of BC is equal to Z of B into Z of A plus Z of C divided by Z of A, Z of B, Z of C. This is equation 4. Okay. In star connection, this would be equal to Z2 plus Z3. Okay, Z2 plus Z3. Similarly, equate the Z of BC equation and we would be getting this equation. Name it as equation 6. Then similarly, considering the terminals A and C, and here now Z of AC, that is Z of AC, that is equal to Z of B into Z of A plus Z of C divided by Z of A, B and C. Okay. In star connection, that would be equal to Z1 plus Z3. Again equate it and you would be getting this equation. Name it as an equation 9. Now we should be subtracting equation 3 minus equation 6. Whatever we have written. Why? Because we would be getting one simple derivation here. Subtract it, solve it like this. Okay. Do the mathematical steps here. I won't explain those mathematical steps. I hope that you might be knowing it. I'm just going to show this now. Here I've done the mathematical steps of subtracting in both sides. Then do the denominators are same, so this both numerators you should be adding together, and remove the brackets. Z2 Z2 would be getting cancelled. You would be left with Z1 minus Z3. Then solve like this. Multiply the brackets. You would be left with ZA ZB minus ZA ZB would be getting cancelled. Okay. Then write the remaining equation and name this equation as equation 10. Now what we should be doing, add equation 10 and equation 9. That is, whatever we have got here, right, equation 9. Why we are adding equation 9? Because we need to cancel this Z3 term here. You can see here this Z3 term. If we add this Z1 minus Z3 and here Z1 plus Z3, our aim is to get the value of Z1, right? Z1, Z2 as well as Z3. So now if we add the equations 10 and equation 9, we can cancel this Z3 term. Okay, so that's why we are doing this. After addition of equation 10 and 9, in this side Z3 would be getting cancelled. We would be left with only Z1 term, that is 2Z1. Then add this again, the denominators are same. Do the mathematical calculation, you would be left with ZA ZC divided by ZA plus ZB plus ZC as the value of Z1. Okay, in this way we are deriving for Z1. Similarly, do it for calculate the values of Z2 and Z3 in the same way, that is subtract equation 6 and equation 9. What is equation 6 now? This is equation 6 and equation 9 is this one. Okay. If we subtract these two equations, we know that we can cancel one term, that is Z3. We would be left with only Z2 minus Z1. Okay, that only see we have shown in the simplification part. Z3 would be getting cancelled, we would be left with Z2 minus Z1. In this part also, denominators are same. Combine the numerators, remove the brackets, multiply it, and we would be getting this equation. Name it as equation 12. Now, and our goal is to get the value of Z2, but we have here Z1, that is minus Z1. So whenever we have the value of Z1, that is here we have the value of Z1, that is Z1 plus Z2. So we should be considering this equation now, that is equation 3. So that only I have considered here. Add equation 12 plus equation 3 so that we can cancel Z1 and we would be left with only Z2 in this side. That would be Z2 plus Z2 is 2Z2. Do the simplification part, 2 would be getting cancelled and our final value of Z2 we would be getting it as ZA ZB divided by ZA plus ZB plus ZC. That name it as equation 13. Similarly, find the value of Z3 by comparing the equations which you have written. Compare it, which our goal is to cancel out all other impedances and we would be left with only one single impedance, that is Z3, that is equal to ZB ZC divided by ZA plus ZB plus ZC. Name it as equation 3. Like this we should be calculating the values of Z1, Z2 as well as Z3. Okay. So here if we observe the common relationship between Z1, Z2 and Z3, in all the cases the denominators are the same, ZA plus ZB plus ZC. Only the numerators change. In place of Z1 we have ZA ZC, in place of Z2 we have ZA ZB, Z3 we have ZB ZC. So now compare this with the figure here. After the connection of the conversion of delta network to star, that is this is delta and we want to convert this delta to star network. So our value of Z1, what we would be getting here, we would be getting as ZA ZC in the numerator, that is this is ZA and ZC, that is opposite to that of Z1. Which and all are the impedances there? That is ZA and ZC, right? That you should be considering for Z1. Opposite to Z1 we have these two impedances, right? ZA ZC divided by, in the numerator is same, ZA plus Z, that is sum of all the impedances, ZA plus ZP plus ZC. Similarly, if you want to calculate Z2, opposite to these two we have ZB as well as ZA. So that is the value here for Z2. Here you can see that we have ZA ZB, right? Opposite to Z2 we have these two impedances. We should be multiplying these two divided by sum of all the impedances. Similarly, if you want to calculate Z3, these two ZB and ZC are the opposite impedances divided by sum of all the impedances. That only we have written here, that is ZB ZC. Okay, like this you should be considering in order to convert delta network to star. This is the derivation part. Hope it is clear. Next we have the conversion of star to delta. That is, now we have gotten our star connection. Now to convert back that star connection to delta, that is the reverse process. We have one more derivation, not a derivation, just the continuation. So now consider Z1 Z2 Z2 Z3 as well as Z1 Z3. That is Z1 Z2 is equal to, so just now we have solved the values of Z1 and Z2. Write that in the bracket. Okay, solve this. That is multiply ZA ZA is ZA square into ZB ZC, and we have here 2 times ZA plus ZB plus ZC. That would be equal to ZA plus ZB plus ZC the whole square. Name it as equation 1. Similarly for Z2 Z3, write the values, solve it, and write like this you write it. Name it as equation 2. Similarly do it for Z1 Z3. Substitute the values of Z1 Z3. Okay, solve it and we would be getting one equation. Name it as equation 3. So now these 3 equations you should be adding them. Okay, add equation 1, 2 and 3, that is Z1, Z2 plus Z2, Z3 plus Z1, Z3. Add them and what we would be getting? Here again, in all the cases, the denominators are same. Okay, keep it as one common denominator and add all of the numerators. Okay, that only I have written it here. Then after that, in this numerator part, ZA, ZB, ZC, in all the numerator, this is common here, right? Take that ZA, ZB, ZC common and write the remaining terms. In this case, one extra term is ZA, in this case one extra term is ZB and this is ZC. Divided by ZA plus ZB plus ZC, the whole square. So that's why we have two ZA plus ZB plus ZC terms, right? One of them we can cancel it and we would be left with ZA, ZB, ZC divided by ZA plus ZB plus ZC. Okay, name it as equation 4. Now, in equation 4, we know that ZA, ZB divided by ZA plus ZB plus ZC is equal to Z2, which I have already proved. Okay, we know that. Now what to do is substitute in that equation 4 in place of here, that is ZA, ZB is divided by ZA plus ZB plus ZC. In place of here, we should be substituting Z2. Okay, and keep the LHS as it is, that is Z1, Z2 plus Z2, Z3 plus Z1, Z3 is equal to Z2, ZC. Then solve for ZC. Okay, because we need to solve for star to delta, so we need to be finding the values of ZC, ZB as well as ZA. Okay, ZC, keep it in one side, bring this Z2 to another side. Okay, ZC is equal to, here in this equation we can split these two terms, that is this is as one term and this as one term. Split it, and in this term we can see that Z2 is common, take it outside. Z2 into Z1 plus Z3 is divided by Z2, so Z2 would be getting cancelled. This you keep it as it is. So our final value of ZC, we would be getting it as Z1 plus Z3 plus Z1 Z3 divided by Z2. This is the value of ZC. Similarly, solve for ZA and ZB, that is also in equation 4, we know that what is Z3 equal to. Okay, Z3 is equal to ZB ZC divided by ZA plus ZB plus ZC. That is, we have here ZB ZC and ZA ZB ZC. So this is equal to Z3. Again in that equation, substitute in place of this term as Z3 and solve for ZA. ZA is left, right? If we consider ZB ZC, this is left. So here ZA. Similarly, take ZA in one side, bring Z3 to another side, so it will be getting divided. Okay, split it like this again. That is, split this term and this term so that we can cancel Z3 and we would be left with the answer of ZA as Z1 Z2 plus Z1 Z2 by Z3. Okay, this is the answer of ZA. Similarly, also in equation 4, we know that ZA ZC divided by ZA plus ZP plus ZC is equal to Z1. Right? So what is left in the numerator now? ZB. So Z1 ZB. Okay, bring ZB to one side, solve this, and like this you would be getting the value of ZB also, that is Z2 plus Z3 plus Z2 Z3 by Z1. So like this we have got the answers of ZA, ZB as well as ZC. So here also we have one common relation of conversion of star to delta. Okay, so I'll write it here. So in case of conversion of star to delta, that is, if you want to find the values of ZA, ZB, ZC, Z1, Z2, Z3, yeah, this should be in the same direction in both sides also. If I write ZA, ZB, ZC like this also should be written Z1, Z2, Z3, okay, in the same direction. Now, see, to find the value of ZA, again the same thing. Consider in case of ZA, what and all are the two resistances which meet in star connection here. For ZA, we have these two opposite resistances, that is Z1, Z2. Okay, so that's why we should be doing Z1 plus Z2 plus the multiplication of these two, Z1, Z2 divided by the other impedance, Z3. Okay, that is sum of first impedance plus sum of second impedance plus product of two opposite impedances divided by the remaining impedance, that is Z3, in this way. Okay, for ZA, for this connection, what we should be doing, these two, this plus the product of this divided by the remaining impedance. Similarly for ZB, these two, that is Z2 plus Z3 plus Z2 Z3 divided by Z1, that only we have written here, right? This equation. Similarly for ZC, Z1 plus Z3 plus Z1 Z3 by Z2. Okay, so this is the relationship. So hope this derivation is clear to you all. I've tried to explain it how much ever it is possible. So this derivation would be coming for 10 marks, either star to delta or delta to star. You should be knowing how to write the equations. Equations you can write it in your choice, but it should be meaningful, and it should be the evaluator should understand what you're writing. Okay, yeah. So this was the main derivation of conversion of delta to star. Hope you understood this. From the next session we are going to solve problems. Okay, thank you.